STP or Spanning Tree Protocol. In this video, I'm going to talk about again STP and other features related to the STP. First, let me to start with one scenario, with one example, and after that we can continue the learning about the STP. You know that in all of the STP scenarios we need one table. We call it bandwidth cost table. Okay, let me first review this table because this table has been changed over the years. For example, here as you can see, we have the table that is released in the 1998, and as you can see, the cost of 10 megabit per second interface is 100. You learned about it, and after that 100 megabit per second 19, 1 gigabit per second 4, 10 gigabit per second 2, and also for the 100 gigabit per second and 1 terabyte per second, this is not available, this is not applicable. Why? Because in that days we didn't have the interface with more than 10 gigabit per second bandwidth. Okay, but today we have more bandwidth in our networks about one interface. Because of that, this table was released in the IEEE in the 2004, and this is the table that as you can see we have the for example 2 million for 2 million cost for 10 megabit per second bandwidth, and for 100 megabit per second we have 200,000 cost. For 1 gigabit per second we have 20,000, and for 10 gigabit per second 2,000, for 100 gigabit per second 200, and for 1 terabyte per second 20 as the cost. As you can see, when the bandwidth is increasing, the cost is decreasing, and it is okay. But let me to say that actually this is the short pass cost method. We call it short pass cost method. And after that, here in the right side you can see the long pass cost method. This is the long pass cost method. We can use both of them. Okay, for example, in the networks that we don't have any interface with more bandwidth, for example the 10 gigabit per second, we don't need to use this type of cost. Okay, but if you want, you can change the type of cost that you are using in your scenario. The command is this command, spanning tree, okay, then pass cost, for example method, then the short and long. But also here we have some default values. For example, when you are using PVST or per VLAN STP, or let me to say PVST or STP, okay, you are using STP or PVST or RSTP, okay, the default method is the for example short pass cost method. But when you are using the MST IEEE 802.1s, the default method is the long pass cost method. If you need to find which method now is using, you can use the command show spanning tree summary. Look at here, show spanning tree, then summary. Okay, let me to show you in our packet tracer. Here we have one switch without any configuration. This is CLI, then show spanning tree summary. Now can show us that we are using the pass cost method of short. Okay, because of that, this pass cost method now is available in packet tracer. Maybe you don't have the command of changing of the pass cost method spanning tree pass cost. As you can see, we don't have this command. Okay, and now we can talk about this scenario. You know that here we are using by default the IEEE cost for the year 1998, and because here we don't have any interface with more bandwidth than for example 10 gigabit per second, we don't need to change the, for example, pass cost method to the long pass cost method. And here as you can see, I am using only the same type of the interfaces, and all of these interfaces that are available here are fast Ethernet, and you know that the bandwidth of the fast Ethernet is 100 megabit per second. So easy. Let me to talk about this scenario here. As you can see, we have this order of the MAC addresses. MAC 1 has less value than all of the other MACs. Because of that, you know that the switch 1 is the root bridge for this scenario. Look at here. This is the RB or root bridge. Now we need to find the root port in each for example switch, and you know that the root port is the port with lowest cost, okay, to the root bridge in each switch. Okay, for example, in switch 2 we have two ports, port 1 and 2, and also port 3 and 4. Port 1 and 2 have lower cost, okay, in compared with the port 3 and 4 to their switch 1, but we need to find one of them and use one of them as the root port. Okay, we need to use the tiebreakers. Here we are reviewing the tiebreakers. You know that the first tiebreaker says that each port connected to a lower sender bridge ID, but as you can see, both of these interfaces are connecting to one switch. Let me to go to the next tiebreaker, lower sender port ID, because the port 1 connected to the port 1 of the switch 1, and the port 1 of switch 1 has lower port ID than the port 2 of the switch 1. We can say the port 1 of the switch 1 that is connected to a lower sender port ID, okay, this is the root port or RP. Okay, in switch 2 it is obvious that the port with lowest cost to the root bridge is the port 1. Also in switch 4, again in the switch 3, in switch 4 again this is obvious that the port 2 has lower cost to the root bridge. Okay, we can easily find the root port. But in switch 5 again we need to use the tiebreakers, because from the switch 5 to switch 1 we have two paths. The first pass from the port 1. From the port 1 we have two link with the for example cost of 19 equal to the 38, and also from the switch 5 to switch 4 then switch 1 again we have two link, and the cost of pass, total cost of pass is again 38. We need to choose one of the port 1 and 2, the port 1 connected to the switch 3 and the port 2 connected to switch 4. Because of that, the port 1 connected to one switch with lower sender bridge ID or bridge ID. Because of that, the port 1 is the root port. Also about the switch 6, and we need the same condition. Switch 6 with port 1 and 2 with same cost can reach to the root bridge, but as you can see, the port 2 connected to switch 3, the port 1 connected to the switch 4, and because the switch 3 has lower bridge ID than the switch 4, the root port is the port 2. So easy. Because of that, until now we did the second step in the STP process. Okay, the third step is finding the designated ports. You can see here all of the interfaces of the root bridge are designated port. Let me write here, this is designated port, this is designated port, and also this is the designated port, the port 4 of the root bridge and the port 3 of root bridge. Okay, also we need to find the root bridge, the designated port in all other links. For example, in the link between switch 2 and 3 we have the same cost for both end of the link to the root bridge, but the switch 2 connected to port 4, the switch 2 has lower bridge ID than the switch 3. Because of that, the port 4 of switch 2 is the designated port. Again, between the switch 2 and switch 4, as you can see, between the switch 2 and switch 4, the switch 2 and switch 4 have same cost to the root bridge, but the switch 2 has lower bridge ID, and because of the first tiebreaker, we can say the port 3 of switch 2 is the designated port. Okay, we need to find the designated port now in the link between the switch 3 and switch 4. For example, as you can see, the port 4 connected to the port 3 of the switch 4, the port 4 of switch 3 to the port 3 of switch 4. Here again we have the same cost between the switch 3 and switch 4, but you know that the switch 3 has lower bridge ID than switch 4 because of its MAC. Because of that, we can say that the port 4 of the switch 3 in this link is the designated port, and also the port 3 of the switch 3 is the designated port in the other link. After that, in the link between switch 3 and switch 5, because the switch 3 has lower cost to root bridge, we can say the port of switch 3 is designated port, and also in the link between the switch 3 and switch 6 we have the same condition. Also, between the switch 4 and switch 6, the switch 4 has lower cost to the root bridge than the switch 6. Because of that, we can say the port 5 of switch 4 is the designated port, and also in the link between the switch